Hey there, ladies and gentlemen. So if you take a look at these, we're dealing with some fill-in-the-blank proofs. Now, don't get tricked into thinking like this is so much easier because I give you all the options. In fact, this is more difficult because it's not your reasoning anymore; it's someone else's reasoning that you have to evaluate. So the best thing we can do is actually look just at the diagram and see how we in our heads can do that planning thing, how we'd actually would prove this, and maybe even mark up the diagram quite a bit as we're being told stuff. So we're given that I'm sorry, yx and wx are congruent. So yx, boom, oh, sorry, my pad slipped. Boom, and yx are congruent, and we're told that xz, which is an up and down line, bisects wxy, which is a top angle. Now this is suspiciously close to the test question that almost everyone messed up, and it's important to note that we're saying the line bisects the angle, and so all we know is that the angle is cut in half. We don't know anything about yw whatsoever. What we want to prove is that yz is congruent to wz. So we want to prove that this is congruent to this. So, if we're thinking about how we would do that, and this is again kind of thinking about the test question that you just took, the test you just took. A lot of people miss kind of a very obvious thing. If I want to prove this is congruent to this, I can't do that directly. Like, there's no way to do it directly. What I have to do is actually back up a step and prove something that would force these two sides to be congruent. Um, and the way to do that is to think about what they're attached to. Like, here's a good example. I think I maybe mentioned this to a couple people in class. But let's say you go up to a teacher, like I don't know, like Mr. Johnson, right? And you want to know how old Mr. Johnson is. In fact, well, let me back it up. You don't want to know how old Mr. Johnson is. You want to know if Mr. Johnson's at least 16 years old. But you can't ask him that directly, like, because it's too on the nose. It's maybe kind of rude to ask him that. But what you can do is say, "Hey, Mr. Johnson, do you have a valid driver's license?" Think about that question. If you ask Mr. Johnson if he has a valid driver's license, it would also tell you if he was at least 16 years old, because being at least 16 years old is part of having a valid driver's license. So that's kind of the same idea, the same logic you take to this problem. If you want to prove the red segment is congruent to the green segment, what you actually have to prove is that the things they're attached to are the same. Namely, this triangle and this triangle. So if you prove those two triangles are congruent, then YZ and ZW have to be, because of congruent pair. I'm sorry, corresponding parts of congruent triangles are congruent. So you're actually really close because you do have a side and you do have an angle. So I think if you just think about this middle shared reflexive side, dude, you're in business. So I think that I'm gonna hope that's what this proof is gonna reflect for us, all right? So let's check it out. We do have things at the bottom we have to pick. So we're told yx is congruent to wx. Well, look at that. It's actually stated right here. So I bet that's going to be a given. So I'm going to cross it off my list. I'm going to write given right there. I'm told zx segment bisects the angle yxw. Well, that's also a given. Look at that g. That's out of control. So look at statement number 3. The angle yxz is congruent to the angle wxz. Well, those angles are those two angles right here. Those two angles have to be are the result of the bisection. So I'm going to look for something like definition of angle bisector. Burr. Definition of angle bisector. We have xz congruent to xz. Well, xz is this middle piece that's shared in both. So that's got to be the reflexive property of congruence. I'm going to go ahead and just shorten that to reflexive property. Now we have these two triangles are congruent, which is no surprise, because we were giving a side length here, an angle here, and a side length here, which means that we're probably going to use side angle side congruence. Again, I'm going to go ahead and shorten this. And then as a result, the two are congruent. Well, that's going to be because congruent parts of congruent triangles are congruent. Bam, that is our proof. So again, just because you're given fill in the blank, I implore you, do not just start guessing randomly. Stop and think about how you would write the proof. Think about that brainstorming slash kind of like rough draft phasing of the proof, where you're just kind of thinking how you would write it out. Mark up your diagram, use colors if you have access, bold and sketch out if you don't, and you will have success in this problem. Let's look at this guy. So remember to mark, okay, so ABCD is a parallelogram. I want to prove that ABE is congruent to CDE. So let's check this out. So ABE, so upper triangle, is congruent to CDE, which is lower triangle. So we want to prove the upper and lower triangles are congruent. So the diagram's not marked. I'm told it's a parallelogram, which could mean a whole lot of different things. So what we would probably want to do is take a second and review, and again, stop the video if you don't know, review the properties of a parallelogram, particularly their sides, their diagonals, and their angles. So stop the video now, go find a different video, review the information, and come back if you need to. Otherwise, just stay on the line. And we're back. Okay, so how would we prove these triangles are congruent? Well, we have to take advantage of a couple different things. Um, we know this all the sides are parallel, which means we could have access to angles, but since you review the properties of parallelograms, you also know that opposite sides are automatically congruent. So that would immediately give us one side length, one up and one down. You should also know that diagonals bisect one another, which means that it's cut thusly, which gives us actually three sides. Now, we might need some other things about angles, but I think if we have side congruence, that actually might be enough. So again, it might be confusing, but that's only going to be confusing if you didn't stop and review the properties of parallelograms, particularly the ones that tell you that opposite sides are congruent and that diagonals bisect one another. So now it's just a matter of picking the pieces out of a proof. So let's get to it. So we have to think about a given information. Well, given information is that ABCD is a parallelogram, and lo and behold, there it is in our list. So ABCD is a parallelogram. In a parallelogram, opposite sides are congruent, while opposite sides in this particular case will be the upper and lower. So AB and DC. In a parallelogram, diagonals bisect one another. And that's actually going to have two statements, so I think we're going to have to deal with two different side lengths. The first, let's just say, is going to be these guys. So AE congruent to EC. And then the other set of parallelograms, so that'd be DE congruent to EB. And then since I now have shown three sides, side 1, side 2, side 3, well, of course, it's time for us to write a triangle congruence statement. I got all country there for a second. ABE is congruent to CDE. Okay, so again, it's about actually writing the proof in your head first before you're writing it on paper. So those are the two fill-in-the-blank proofs. Not too terribly difficult. Now, if there was some terminology here, maybe a style choice that was different, that's okay. I mean, you should be prepared on this test because you know that part of the test was written by any teacher at Battle to make some style choices that you're not used to. So you got to be dynamic. You got to be ready. You got to be kind of be malleable. So if you don't see something exactly the way you saw it in class, you're not going to freak out. You're going to realize you've seen it before, just in a different way, and you're just going to kind of roll with it. All right. So that's this part of the video. I think this is part 4. I'll see you guys in part 5. Yay! And 30.